So a couple anomalies here. I removed the switching power supply and I put the trip light back in. This is an old power supply, but still works really good. And it's obviously not a switching power supply. And if you look back in here, I don't know if you can see, I'll try and shine a light back in there a little bit. You can see I went with my idea temporarily of putting BNC connectors on. And I got BNC connectors that were able to take up to number 8 wire. And I trimmed down the wire from this so it wasn't quite as long as number 8, quite as long. Also, even though it's really thick on the conductor, or the insulator, I don't know if I'll believe it's number 8. Let me just put it that way. This seems to work really good. A couple of things I did with this was actually there's some. I checked where my voltage loss was at each state of through this, as far as coming out through the connectors, up to here to the connectors, across the ammeter, and then there's some glass fuses in there. The glass fuses, the retainers they were holding, even though the fuse was somewhat tight in there, you could move it up and down, and I looked and those retainers are only really rated at, I think, 15 amps. So what I did is I soldered the fuses in, and that actually took a lot of the loss away. The ammeter itself on this, it can't be trusted. When I'm putting out about 17, 18 amps, this is saying closer to 30. And I know that's not true. Well, mainly because this is only a 25 amp power supply, but I did check it with a ammeter. So anyhow, that part is all taken care of, and I'm able to get, oddly enough, I get a full 100 watts out on both of these transceivers right here. The funny thing is this one here, the ICOM, when I was using the switching power supply that was, I believe it's rated at 30 amps, this would not put out a full 100 watts with the switching power supply. When I put the trip light back in, I now get a full 100 watts out. So that's kind of odd. And I know that the other power supply is capable of putting out 100 watts with this, because that's what I used when I did the testing down at the workbench. So the other thing is, I get on a net. It's a Western Pennsylvania Health and Wellness net, and it's on weekday mornings on 3.983 megahertz. Let's see, what else can I say? It was every weekday at 9 o'clock a.m. And I check into that. So I was originally using the gap antenna, and I went out and revamped that antenna that I made for the NVIS, which is that works a lot better for closer radiation. So if you think about how the waves bounce off the ionosphere, if you kind of think about taking a garden hose with a regular antenna, and your garden hose is shooting at an angle like that, then the skip hits that and comes down at an angle there. Well, with NVIS, it kind of almost, think about shooting your hose straight up in the air, and the waves come down a lot closer to where you're shooting them up. So since these are all probably within 110 miles of me on that net, it works a lot better when I use that NVIS type antenna as opposed to the Gap Titan. And I'll take you out and show you that in a few minutes, really, what the modifications I did to it. All I did was lengthen it with some wire, but again, it's pretty ragtag. I used the one-to-one balun that I made, and I just shored up the connections a little bit better, and I added about 30 feet of wire to each end of it. Now, the crazy thing about that, when I put it on here with the internal antenna tuner, it tunes right up. It gives me a almost one-to-one match. Is pretty low. When I try to do it on this using this tuner, I'm still up about 2. This tuner will not get it down. However, with this tuner here on the Kenwood 820 and the, what is it, the AT200, I can tune my 80-meter dipole, or the antenna I'm using, I can tune that to 160 meters. So it'll tune to 1.9 megahertz, to almost like about a 1.2 on the match. But if I try to tune it with this one, the internal tuner, it will not tune it. So just some of the anomalies. Now, I haven't really tried to talk to anyone on this because the band's been so dead. In the mornings when I'm on, there's nobody around. But I'm just really curious to know how it works. So we'll go out and take a look at the antenna I put up, and the NVIS is what the Near Vertical Incidence Skywave is what it stands for. And again, it's when it bounces off the skywave, it's coming almost straight back down to Earth, as opposed to coming down at an angle maybe over in Europe or in Asia, you know, depending on how far it goes up. So that's kind of the whole idea behind that, and that works best. And the HF band, probably, I think about the highest frequency you'll get it to work is the 7 megahertz band. So let me take you out and show you the antenna. All right, so there's the Gap Titan DX, and currently I'm using the Coax that feeds that I brought in, and it comes over here to the, hey, you're probably thinking, where's that antenna that's so stealthy? I know it's a little bit windy, so I'll get closer here. So let me see if I can find the antenna. I'm going to follow the Coax cable up. And it was something I just threw together. You can see, oh, up there, I'm using that same box. So what's that? Probably about, I don't know, 15 feet off the ground. And I'm using the same wires too. Let's see if you can see them coming off the end. They're just a straight wire. My idea was to make it almost like an inverted V. But I didn't have enough coax handy, so I got it about as high as I could, and the coax is ideally coming straight down, and then it goes across the ground. But the wire runs through the trees, and it goes way over there to a tree. Can't see if you can, probably can't see past this tree, so. All right, and then there it is, and it's coming. It's probably maybe 4 or 5 feet off the ground at the end point there, and it does the same thing on the other side. But like I said, not a lot of thought or time and work was put into this, and it really performs quite well. All right, and then one thing I do want to check is, take this and we're going to turn this to 3983, and we're going to go through the bird, and I have a 100 watt slug in there. And just real quick, I want to see what kind of power output I'm putting around in this band, right around the area where I'm transmitting. Right now the coax here is from the birds connected to the back and goes into the 590, so we should see around 100 watts. And then what I want to do is I want to take it out and put it at the connection just before the antenna, and then that's only about 20 feet of coax that would go from the ground where I have this up to the antenna. So we'll just see what kind of loss we have, and I'm going to estimate there's probably close to 100 feet of coax by the time it gets up to that antenna. So without doing an accurate measurement, you can guess about 80 feet how much of a loss we're going to have. And it starts off, let me turn this down a little bit. It starts off with, up in here, it's like LMR 240. This goes down, and it goes through the floor, and then across the floor and out. I think you remembered in one of my videos I ran all that. But down in the basement, it joins up with some old, not old, but some RG8. The thick stuff, and that's what makes its way out to the antenna. And when it gets out there, it goes through conduit to the antenna, and then it converts back to once it gets out there, I had to make the lead, so it converts back to the LMR 240. So we're gonna give it a shot and just see. I have it, I'll put it on FM, and that way I'll get my full power out on FM. Zoom you in there. It's a 100 watt slug, so you'll be looking at the 100 watt scale at the bottom here. so as not to make a lot of interference. We're not going to do it for very long. Let's see. Oh, that's AM. Let's try FM. And I'm getting some glare. There we go. So it's going up past 100 watts. Unfortunately, I don't have a 200 watt. I have a 250 slug down in the shop, and when I put that in, it goes just a smidgen past. And that's a technical term, smidgen. Just to take a little bit past 100 watts. So the main thing I want to see is how much power I have out at the antenna. So we're just going to connect this antenna right back up and take this setup with this same meter outside and give it a shot out there. All right, here we are outside. That's full, so almost 100, so not that much of a loss. So pretty impressive. I did want to add that antenna out there, actually, oddly enough, is resonant right about there, and that's without the antenna tuner. You can see it's almost about a 1 to 1.5 on the SWR right there. So I realize it not being far enough off the ground and not being a true inverted V is going to affect the radiation resistance, but with the antenna tuner, it works. So you can watch the SWR. That's with the tuner in at 3983. It barely even moves. All right, so there you have it. And I would have thought it would have been a lot lossier out there at the actual antenna, but it didn't appear to be. Maybe a handful of watts, 5-6 watts, but good to know. I'm sure as I go up in frequency, it probably would increase. I'll have to try that maybe with the gap antenna, maybe on 28 megahertz or even 50, and see what we get. But just a short video to show you some of the findings here, trying to get things fine-tuned and everything working, and we'll see if we can get you a click in here with the morning wellness net for the northwest or western Pennsylvania. So we'll give that a shot as well. All right, and before we go, a quick look at the TS820 here, and haven't had any issues with the display ever since the last repair, so that's a good thing. So we'll show you the SWR here on 18999, basically 1.9, and it's with that 80 meter antenna that I have practically laying on the ground. Try to move these cables out of the way here. So let's see, turn it on cow. I don't have enough hands to do this. And we'll hit send. Cow's good. Turn on SWR. 1.5. Pretty impressive. So I'm kind of anxious because I've never made any contacts on 160 meters. So we'll see how that works out. All right, we're going to get ready for the Western Pennsylvania Health and Wellness Net on 3983, weekdays at 9 a.m. It's got kind of a high noise level here, so don't really expect a lot from 80 meters this morning, and I looked, and the propagation looks kind of poor for the morning, so we'll see how it works.
Wellness Net. My call is Kilo Charlie 3 Kilo Foxtrot Whiskey. My name is Carl Charlie Alpha Romeo Lima, and I'm located in the northeast section of Somerset County. This is a directed net that beats on 3.983 megahertz, Monday through Friday morning at 9 a.m. local time. The purpose of this net is to check with amateur radio operators located in western Pennsylvania and surrounding areas. Sound great, K3MIY. How about W3DDH? Good morning, Carl. W3DDH. No traffic. Hey, Don. Good morning. Any other callers in Clarion County, please? Moving to Crawford, KA3AJI.
Good morning, Carl. KA3AJI. No traffic.
Hey, Ted. Sound loud this morning. KA3AJI. Good morning. KC3KXB.
Good morning, Carl. KC3KXC. All is well here. Have a good day.
Hi, Tom. Sounds good. And same to you, KC3KXB. Have a KC for your QH.
So I even got a report of a loud signal this morning, and that's all thanks to a piece of wire hung in some trees. So hey, thanks for watching.